Hi, my name is Juan Miguel, and today I will give a presentation about the Home Media Center. This is my project work. At first, I will explain what is a Home Media Center, and I will quickly introduce what is a Raspberry Pi, since I'm using the Raspberry Pi for this project. I will explain also about the idea, the interface I developed, and the potential of the idea. So at first, what is a home media center? A home media center it's basically a server which is connected to an output like a TV screen, and it also has some input devices connected. For example, a computer, a USB storage, or even video game consoles. The main purpose of the home media center is to play media file such as movies or video or music, for example. And so that this way we can, for example, play a movie that we have stored in the computer and we can watch it in the output device in the TV screen. So what is a Raspberry Pi? I guess many of you might know what is a Raspberry Pi, but anyway I will quickly explain. A Raspberry Pi it's a small computer device, and here it's basically a small computer. It's very cheap, and it was released 2 years ago in the 2012, and it has low capabilities, but they are really enough for the project. And making a link between this slide and the previous one, I marked here which one is the input and the output. The input here we can see it has 2 USB ports, Ethernet port and a SD reader. And as output it has HDMI, RCA and one jack 3.5 millimeters. It also has GPIO input output pins, and these pins can allow to the developer to interact with the environment using the Raspberry Pi. Here I choose 4 nice examples of what we can do with a Raspberry Pi. The first picture we can see it's a camera which is connected to the Raspberry Pi. The camera is pointing outside all the time, and the Raspberry Pi is running a face recognition algorithm. So when it detects a face, it will take a picture, it will crop the face, and it will publish the face in the internet, in a Twitter account. The second picture it's a quadcopter, and the third picture it's a 3D printer, and the fourth and last picture is a cluster made of Lego. Now I will explain the idea, how I developed the home media center. So basically we have a script which is running all the time, and it's waiting for commands. It will read the command and it will try to perform the command. Some commands might be like shut down the Raspberry Pi, or play some certain media file, or actually whatever. I also install a web server, and this web server, the main purpose of the web server it's because of security issues. It can validate input, so this way the user is not connected to the script, and this way the user cannot, for example, send some bad commands to the script. We always have the web server in the middle, and it will validate the inputs and then it will send the input to the script. Another reason that I'm using the web server it's because it's a widespread technology. Nowadays if you buy some device, all of them might have a browser, for example. And some people who are not very friendly with technology, they don't have to worry too much about it, because as I said, they have to pre-install the web browser, and the only thing they need to do is just go to the web page and use it. Otherwise we had to program different devices, different apps, so it's more difficult. So for example, the user he can connect, for example, to the web server, and it will perform some action. For example, it will click in some file he wants to play, and this will come to the web server. The web server will take that action and it will interpret what the user wants to do. and it will translate this action to a certain command, and it will send a command to the script. Here I wanted to comment a little problem I have when I was developing this project. So I was using a media player, OMX player, and when it's running, when it's playing, for example, a movie, I can, for example, press the P key, and this way I can pause the media. At first, I found a library in Python that I can send information to the process. So, for example, I can send the letter P to the process, and then the process will interpret it like I press the P, and it will pause the system. But I had a problem with the arrow keys because I cannot send anything. The arrow keys doesn't have any representation, so it's not like, for example, a char, or they don't even have any ASCII code. So I think I lost like 1 week trying to figure out how to solve this problem, but I couldn't. So I gave up with this problem, with this library, and I use other library. This library, it's imitating the keyboard, so this way I can send not only letters, but also I can press keys like escape, control, alt, the arrow keys, of course, and everything. So yeah, the script will receive the command. It will try to perform the command as I said previously, and it will send back to the server if it was successfully performed, or if we had some error. From the web server to the user, it will send a response. So we always send a different response depending on the error, for example, or depending if it was successful or not. It really depends. Now I will explain about the script which is running all the time. I will explain a little bit how it works. This is the most important part. Here we can see the main difference between this home media center and the rest of them, because here I put some innovative idea, kind of. So when we start the Raspberry Pi, it will check the networks. This means that it will check the wireless networks, it will retrieve wireless networks, and it will check if we have the wireless networks stored in our Raspberry Pi. If there is a match, then it will try to connect to the wireless network. I use a wireless dongle, so it can also connect to the wireless networks, not only via Ethernet but also wireless. If it doesn't find any suitable network, or if it doesn't find any network at all, then it will set up a new hotspot. If it finds the network, it will try to connect to them. So for example, if it finds two networks, and I have those networks stored, it will try to connect to the first one, and if it cannot connect to the first one, it will connect to the second one. And if it's not working anyway, it will set up a new hotspot. This is important because we always need to have a network. This way the user can connect to the network and it can control the server. Either if it's working or if we set up the hotspot, we will mount the shared folders. This way we can share files among the network, so we don't have to, for example, plug an USB pen drive, copy a file, unplug it to the server, and so on. And finally, it will be waiting. As I said, it will be waiting for the commands. So to make more clear this idea, this is basically asking ourselves, like, does the user have a network at home? If the user has a network at home, why not using it? I've seen some home media centers which they use the wireless capability as well, but they don't connect to the home network. They always start a new hotspot. So I was thinking this is really inconvenient because, for example, if we have our smartphone connected to the network, to the wireless network at home, if we want to control the server, we have to disconnect from that network and connect to the other network. And this is really inconvenient. So why not use the same network? I've seen also there is some home media centers who also use the same network, but use an Ethernet. but I haven't seen any home media player which also use a wireless network, and yeah, I think it's a very interesting idea. Well, as I explained, otherwise it will set up a new hotspot and it will share the folders. This is the diagram how it looks a normal home media center. So as I explained earlier, we can see all the devices that are connected to the Explorer, to the server, and the server is connected to the screen as well. And here is how it looks when we are using the home media center I developed. So this looks more familiar to us because this is a normal network at home. We have the router in the middle of the whole network, and all the devices are connected to the network. And the home media center, the server, it's also treated as a device, so it also connects to the server, and of course it also has to connect to the TV and everything. And anyway, if we don't have, for example, a router or wireless access, but we have Ethernet port with internet, we can use like this diagram. It will set up a new hotspot, and we can plug the Ethernet to the Ethernet port, and it will provide internet among all the devices. So here is the interface I developed. So I'm not the designer, as you can see. I'm more developer, but anyway, I divide the interface in 3 different sections. So this is a home section. Here, this is basically the web page that we can see when we connect to the web page, the first, yeah, like the home. So here I developed this like in different modules. Here we can add different modules. It's really up to the developer. For example, I developed a weather module, and here we can see the forecast of our city. We can add more cities and everything. And for example, the developer can develop, for example, I don't know, some reminder or something. It's really up to him. This is the settings section. Here we can basically shut down and reboot the system. We can also control the weather. As I said, we can add cities, remove cities, or then we can see the forecast. We can change the hour of the system. We can log in. This login thing, it's basically 2 different things. The first thing, we can enable or disable login. If we enable login, of course we have to log in to reach this interface. And the other thing I developed, it's like a user manager. So we can, for example, add different users. And I developed this thinking that, for example, in a family, every different person in the family, they might want to have a different view, an individual view of the whole system. So for example, one person is not interested in the files of the rest of the family, so he will always see the system as unique, and so every user will see it in a different way. This wireless connection, then, it's the wireless connection that the system will check when it starts. The Ethernet connection, it's basically we can enable and disable it, and if we disable it, then it will start faster because it doesn't have to check if we have Ethernet connection or not. Then the wireless hotspot, it's the name and the password of the wireless hotspot it will set up if it doesn't find any suitable network. And finally, the shared folders are basically a manager to manage the shared folders. Then we have the Explorer. This is a normal Explorer. We can see here folders and files. We can basically see the 3 different things: the local files, so the files that the Raspberry Pi has inside, only in the music folder. Also the USB devices, as I said previously, the Raspberry Pi has USB ports, so we can plug USB devices, and we can also see the shared folders. Finally, this is the last part of the interface. We can see here this is just normal remote. When the media center is playing some media file, we automatically have this interface in our device. So here we can just pause, play, and stop the media, go back, forward, rewind, and control the volume. And finally, I would like to talk about the potential of the idea. If we have internet at home, then why not use internet? So I'm using a media player which also is able to stream content from the internet. So we can also stream like different services, for example YouTube or Netflix. We can do the same with music, for example, as Spotify or Grooveshark they do. We can of course use the social networks like Facebook or Twitter, and I particularly think that Flickr is really interesting because we can see online albums, and I think it's really interesting.